Hello and welcome. We are going to have a quick look at the relationship between current flowing through a component and the heat generated, and for the purpose of this video we're going to call these components, the lamp, the motor, resistor, and in fact all components, we're going to call them resistors. Obviously resistors are resistors, but we can refer to everything else also as resistors. Now when a current flows through a resistor, it gets hot, or it certainly gets warm, but the temperature does rise. Now that also applies to not just these components but also to any wires that carry current as well. Now I know technically this is not a complete circuit, so a current shouldn't be flowing, but just for the purpose of explaining this to you, if I've got a wire carrying a current, it's going to get warmer. So if I have, say, 2 amps flowing through this wire here, it's going to get slightly warmer. If I make this into a thinner wire, it will get warmer still, and if the wire is thicker, then it won't get as warm. And that's all down to the amount of resistance offered to that current. Now this is taken into consideration when we have our appliances. So for example, a laptop will run off less current than a washing machine, so this has a thinner cable that supplies electricity to it, or supplies current to it. That is because the current is lower, so there's going to be less of a heating effect on this cable, and we can choose our fuse in our plug based on that lower current. So for a laptop you might only have a fuse rating of 3 amps because it runs off a low current. On the other hand, something like a washing machine runs off a much higher current, and so therefore we have a thicker cable to reduce that heating effect produced by the current flowing through the wire. This, for example, might have a 13 amp fuse in order to allow that larger current to flow. The next thing I want to focus in on is this idea of a filament lamp. So this is a filament lamp, and it's called that because it has a very thin filament running through it. The filament is just a very thin piece of a particular kind of metal, and the problem with the filament lamp is that it has or it actually gets very hot. The filament is very thin, the current flowing through it makes it get very hot. In actual fact, it's designed to get very hot because when it gets very hot it glows, and that's what produces our light. Unfortunately, that heat, however, is wasted. That heat is wasted to the environment, so this lamp here is not very efficient. If you wanted to have something that was a bit more efficient than a filament lamp, you can use something called a CFL, and that stands for compact fluorescent lamp. And I'm sure you've seen these before. You've probably got some in your house or perhaps at school, or you've seen them somewhere, but they look a little bit like this, and they don't generate heat at all. They generate much less heat. You could probably touch one of these while they're on. In fact, don't do that, but they don't generate much heat at all, and therefore they are more efficient, and therefore waste less energy. Okay, so these compact fluorescent lights are better because they waste less energy, and therefore they might contribute less to the carbon dioxide emissions generated by power stations. The last thing I just quickly want to go through is this idea of energy efficiency labels, and these are labels that you might find on appliances that you shop for in the shops. I've got 2 examples of tumble dryers here. This is one on the right hand side which has a high efficiency rating. That means it's very efficient. It wastes much less energy as heat to the environment than the one on the left. This one has a low efficiency rating, and therefore it wastes a bit more energy as heat to the environment. So this might be something you take into consideration when you're buying these appliances, because you are going to waste less energy, your energy bills are going to be less, and you'll have less of an impact on CO2 emissions. Whereas on the other side of things, while this might be less efficient, the consideration might be that it's possibly cheaper, or something like that. But anyway, that's an overview of the effect of current and heat and energy efficiency. That's me done for this video. Thanks for watching, and I'll see you again soon.